Hi, I'm Francesc Campoy and this is Just for Funk. Welcome to episode number 23 of Just for Funk. Today we're going to be learning how to show the distribution of latencies of a web server using gonum and its plot package. We will start with a very simple web server that is already written, and we will add a new web page /statz that will show us the distribution of the latencies of our endpoint. Does that sound fun? Let's get started. Okay, so I already have my very simple web server right here. We can run it with go run main.go, and then come here, and when we refresh, you will see that it takes something in between, I'd say 0 and 1 second. And why does it take so long? Well, because we're actually waiting for a given time. So we're choosing a float, which is something in between 0 and 1, and multiplying by 1000 and multiplying that by milliseconds. So that's the time we sleep. And then we show how long we slept. Cool. So now what we want to see is what is the distribution of the time we actually sleep. To start with this, what we're gonna need to do is to keep that information somewhere. Let's create I'm gonna create a new type that I'm gonna call stats. That it's going to have two things. It's going to have actually the latest times that we slept, but also a mutex, because we're gonna be accessing this from multiple points, from multiple Go routines. So it's important to make that access safe. So I'm gonna call it data. It's just gonna be time.duration, because that's the time we sleep. And then I'm gonna do sync RW mutex. And I'm doing a RW mutex, read write mutex, because we're gonna have eventually more than one Go routine trying to read at the same time. In this case, maybe RW mutex is not the best solution, because we're gonna be writing more than we're gonna be reading. But it's okay. I'm just gonna keep it RW mutex. Also, you might notice that I didn't give a field name to this field mutex, and these will allow us to do stats.log, stats.unlock directly, because we're doing struct embedding. That's the name of the RW mutex type onto our stats type. Okay, so what I'm going to do is I'm actually going to rename this into server, and I'm going to define root handler as a method of server. That way it will be easier to see who's using what. So we're gonna have var times var s server, and we're going to do s.root. I'm gonna rename this to be simply root s server. And what we're gonna be doing is at the end, we're gonna do s.lock, s.unlock, and in between this is the part where it's safe to add things. We're going to do s.data equals append s.data of d. Also, at some point we'll have too many of them, so we want to drop them. So if the length of data is bigger than, let's say, 1000, we're going to keep only the 1000 last ones. So we're gonna do s.data equals s.data of len of s.data minus 1000 until the end. That is, so if we have 1001, that will be 1, which will drop the first one. Yeah, that looks good. Cool. Okay, so that's this compile. Yeah, that's good. Let me make it a little bit bigger. So it's good to have bigger code for those that watch this on their mobile phones. Cool. So now that we have this information, we need to display it somehow. So let's do another handler, which is going to be also defined on our server. This one I called it statz. At Google, there's a lot of web pages that allow you to see variables and statistics and stuff like that, and they're always called varz, statz. Not sure why. I think it might be because to avoid the conflict, because that way you can still define /stats if you want to, but I'm actually not sure. So if you know why, let me know. So what I'm going to do here is I'm going to lock and then unlock. And then I'm going to simply go over all the data as the data, and I'm going to fprintln into the output data range, and that looks okay. Cool. So now if we run this, we can access this web page and see how long we sleep, which is good. But also if we add access statz, we need to register that. So statz is going to do statz. Let's kill the server, run it again, and nothing happens because we don't have data yet. But if we refresh this a couple times, we should have, there you go. So now we have the time we slept for every single one of the last 1,000 executions of the endpoint, the root endpoint. So if we go here and we refresh, you'll see we have a couple of them. Not that many, but you know, little by little. So this is okay, but we said we're going to be using gonum. And how can we use gonum to display this? Well, there's many ways of displaying data. Something where we can start is to display these on a simple graph. So basically we're going to see the points. So what we call a scatter point, where we're going to be displaying for every single one. So we're going to do at 0, 730, at 1, 572, at 2, 125. So we're going to be able to see if there's some kind of correlation over time. We might be able to see it. It doesn't really look like it, but who knows? So how do we do that? This should be quite simple. What we're going to do is we're going to first do plotter.new scatter. And that should add our import statement up here. gonum.org/v1/plot/plotter. And a scatter requires one single value, which is an xy. Let's see what that is. An xwire is an interface that has two methods, length and given x. So a method xy that given the position, it returns the value x and the value y. Plotter.xy. Okay, so there's this one here, xys. That looks pretty good. Copy, let's see. xys implements the xwire interface. Perfect, that's exactly what we wanted. And you can also copy them. We don't really care about that, at least for now. So, okay, so we need to pass an xy. Var xy, so it's going to be a type plotter.xys. And since that's a struct, and that's a slice, we can, and we know how long it's going to be, we can simply do this and do this, the length of s.data. Cool. Then we can iterate over all the data. s.data, as we're doing here at the bottom. But now, rather than just printing it, we're going to add it. So xys of I is going to be x. The x is going to be float 64 of I, and the y is going to be the float 64 of d. And now d is a duration, which means that if we do a float 64 of a duration, we're gonna get the duration in microseconds. You can see that if you do time.second, for instance, it will say the definition of a second is 1000 milliseconds, a millisecond is 1000 microseconds, a microsecond is 1000 nanoseconds, and nanosecond is 1. So if we do this, we're actually transforming, we're getting the time in nanoseconds. Okay, so we have that, we have our xy's, that's going to return scatter and an error. So if the error is done nil, we should handle it. HTTP. For now, I'm just going to do this. I might change it later. Error.error and status internal server error and return. Do not continue with this. Cool. So now we have the scatter itself, but we need to put it in a plot in order to plot it, in order to print it. So we're gonna create a plot, plot.new, which is a different package, and that returns a plotter. If just gonna copy this, I'm just gonna copy this, copy paste, and I'll definitely change that later. I'm not very happy with that for now, but that's okay. Then we're going to add the scatter on the plot, and finally we should be able to generate an image from the plot. So when you call writer2, you can give the size, the format. Let's do PNG. It's going to do writer2 and an error, and then you can call writer2 to the output. And before I do that, I will also set the header content type to image PNG. Okay, so what is going on with this? Oh, S already defined, so let's call it SC for scatter and SC for scatter. Okay, so let's run it. And now this web page still looks exactly the same, but now here we should get an image. It's an image that has 1, 2, and 3 points. And if we refresh it, actually, I did something kind of cool. So you can do while one, just keep on sending curl to localhost. That way we should be able to refresh this and see how you're getting more and more data over time. I'm not a huge fan of this plot because we're missing information. What is this plot? We have no idea, right? So let's add some extra things. Let's say that the plot title, the text is going to be latency, endpoint latency. The Y text, so the Y-axis, the text is going to be nanoseconds, which really makes me think that I want to do this divided. So let's divide this by float64 time dot millisecond. That will get a millisecond instead. So this is going to be millisecond. And why is this not happy? Oh, this label, not text. And then this is going to be simply sample. Why is this not happy? Oh, text and text. The label for X is sample, the label for Y is ms for millisecond. Okay, so we run this again. Cool. This looks a little bit better. We can see that we get something pretty much distributed all around. So that's cool. In order to get more, in order to get faster data, I'm going to simply avoid the actual sleeping and just say that I slept for that time, but without sleeping. That should make it so we can generate data faster. Way faster. Okay, cool. So now we have a better idea of how data is. And if we refresh, you get all of this information. You can see how it keeps on appearing. Normally, once we get to 1000, we should start seeing them, how they start moving to the left because we only keep 1000. Let's see. There you go. Now you can see that the points are moving to the left as time is going by. Cool. That looks pretty good. Since the fact that they're circles, it makes it kind of hard to follow. So let's change that too. Let's make them crosses. So how do you do that? Well, the way you do it is on scatter, you're gonna say that the glyph style, no, glyphs style dot shape is draw, I think it's draw dot cross glyph. And if that compiles, I'll be pretty happy. That's pretty good. Okay, so now what we did is we changed the shape of the piece of data. So now they're crosses. And I think this is a little bit easier to follow, is a little bit easier to read. Cool. Okay, so now we have this, right, which is pretty good, but still pretty useless because, first of all, I need to refresh continuously, and I'll fix that. Maybe I'll fix that first. But also, I have no idea what the distribution is, right? Like, it looks pretty uniform in between 0 and 1, in between 0 seconds and 1 second, but it could be something else. Like, there's not an easy way to see what is the average in here. So what we're gonna do is we're gonna add one line that shows the average over the pieces of data that we have. Okay, so in order to do that, what we're gonna do is simply keep the same plot, but add one more component. So we're gonna do a plotter.new line. And that also gets a XYS, but so an XYR. I'm not sure how you pronounce that, but whatever, an XYR. In order to create that XYR, we want to have the averages. So I'm gonna do averages is make of plotter.xys of len of data. And we're gonna do is for, just gonna copy that. So data is gonna be, here it's gonna be the same, but here we're gonna get the sum. So sum is gonna be 0.0 at the beginning. And here we're gonna do sum plus equals float 64 of d. And we're gonna do sum divided by that, so yeah, so that's to pass it to milliseconds, but also we want to divide it by the number, which is I actually, so that's perfect. Okay, so we're getting the total number of points. We're getting for every point, we're gonna get the sum divided by how many points we've got so far. And we're passing that to milliseconds. Maybe it's easier to read if I do it like this. Divided by. I wonder if that it's easier to read or not. It depends of how much mathematics you know. I don't like it. I like it better like this. And since I is an integer, and no, that's the duration we need. Yeah, we need the type conversions. Okay, so L declare are not used. That's normal. Let's do one error treatment more, and then we'll change that in a minute. And then we're gonna do that. We add L and SC. Cool. So by just adding this line here, by adding the L to the add function, we're just adding the line too. So now if we run the program again, we should be able to see infinite data point. Oh, because that is actually +1. Because it starts at 0 and that we divide it by 0. That is a problem and we cannot display infinite. Okay, so that is the average. That looks pretty good and allows us to see that indeed it's pretty stable. At the beginning, it doesn't show like it's very stable, but once you go over a little bit, around 200 or so, it starts to be quite stable, and you can see that it's pretty much 500 all of the time. Also, if I want this to be a little bit easier to read, I could change the color of the line and say this is going to be a color RGBA. Let's make it green. So that red, green, blue. No, green is hard to do. Red, green. No, green is easy. 255 and alpha is 255. That should make our line be green. There you go. So now we have a green line. So you can see that there are two different things. There's the points on the green line, like stays pretty stable around 500. And also I could add plotter.new grid. So that returns a grid directly without any errors or anything. So we could just simply add it here. Say add one more grid. Actually, G equals the grid. Cool. How can we make it a little bit cooler? The horizontal lines, the color is gonna be red. Cool. This now looks pretty scientific. Also, I don't want to show the vertical lines. This, it's gonna be 0. Will that make it disappear? I wonder. Yeah, perfect. Okay, I like this one better. So now we have a pretty cool idea, pretty good idea of where this is moving around 500. It's pretty stable. Now, the thing that I don't like is I need to refresh all the time, and also the error handling is awful here. So let's fix first the error handling. What I'm going to do is simply make this return an error. So this will be able to return. I'm going to be using the errors package from Dave Cheney. So it is github.com/package/errors. I really recommend it. I think it's really easy to use and makes your code a little bit nicer, in my opinion. So, okay, so we're gonna return the error, which is could not create scatter. Cool. There we're gonna return could not create line. Could not create plot. Could not create writer to. And I guess that this returns an error. So we could also return could not write to output. By the way, when you do this, errors.wrap, if the error you receive you're passing is nil, then it will return nil, which is nice because then you don't need to do that extra if statement here. So the next step is to make it work. So I'm going to call it error handler of this, and I'm going to define it at the end. So an error handler is a function. Actually, let's make a function that given function of the type of statz, which is basically an HTTP handler that also returns an error. It will return an HTTP handler func. So how do you do that? We're going to return this again. So return a func that does this. And the way it does it is by calling h, and that returns an error. And if the error is not nil, we will display that error and error. Cool. So now when we call error handler and we pass our type, we pass our stats method, which is not really an HTTP handler func because returning an error, this will adapt it by using that error to set it if something goes wrong, but also return an HTTP handler func that then we can use in the handler function right here. And now for my next trick, what I'm going to do is I'm going to change the statz page to be an actual HTTP to be an actual HTML page that will have the PNG image in it, and we will use a little bit of JavaScript to refresh that web page, that image actually, regularly. So let's change that. We're going to do one more thing, which is statsy. Let's call it what? Scatter the PNG. So that's gonna be scatter, and we're gonna need to. So we're gonna change the name of this to scatter, and we're going to define a new function, a new method, sorry, that is TCP handler called stats, and this is going to simply print a web page direct here. So fprintln to the output, and that's going to be a big string. So let's say that there's going to be something like HTML. Let's not call it HTML. Actually, I don't need to make it an actual web page, like a decent one. So I'm just going to have the image h1 latencies stats, and then an image that's going to be statsy scatter.png style width. It's going to be 50%. Okay, and it thinks that might be a directive. So in order just to avoid that warning from goved, I'm gonna use fprintf. That way it should not complain and still work. Okay, cool. So the result now is that when we run our web server and we go here, now we see this inside of a web page, but we still need to refresh it manually. But now, since we're in a web page, we can execute JavaScript. So what I'm going to do is I'm going to simply say this script, and I think this is the first time that you see me writing JavaScript. Things happen. So we're gonna repeat it every 100 milliseconds, and the function we're gonna be executing is going to be setting. So we're gonna get the image, document get elements by tag name of image, var images, for var I equals 0 to the length, images dot length I plus images dot source, images of I dot source equals images dot I of I dot source plus let's do math dot run plus, actually we're gonna need to add one more thing that's gonna be random. So it changes the path, so it doesn't cache it, so it keeps on changing the image. Otherwise it might not work. At least I want to make sure that it does work for all of the browsers we have out there. So we're gonna need to find last index of this, right, plus 1. So that is the source, the current source. Okay, so that substring 0 to var equals pos equals this equal pos plus 1. So we're gonna keep that, and then we're gonna add a random name to source. Is that correct? Who knows? JavaScript is complicated, and I'm not very good at it. Okay, so let's try it and see what happens. So it's not working. Math is not defined. Math.maths. Random number in JavaScript. How do you generate a random number in JavaScript? Using random, of course. Math.capital M, because of course in Go it would be lowercase m and capital R. Here it's the other way around, because yay. Okay, math random. That looks better. Let's see if that makes it better. Cool. Okay, so now it's refreshing it all the time. Cannot read proper resource of undefined. I is smaller than that, because otherwise, oh yeah, my browser is gonna be on fire soon. Okay, that looks better. So there you go. Now we have our thing that is magically updating every 100 milliseconds. Maybe that's a little bit too much. Let's do it every 250. And multiple response rather header calls. Wonder if, oh yeah, look at that. What if I don't do this? If I don't do this, will the error disappear and everything will still work? Even if I refresh many times. Okay, so the problem is clearly that I'm setting the content type too late. But I cannot set it up before. But it still works if I do scatter.png. This is getting scatter.png, the response, the headers in the response. It does say it's image PNG. So in that case, we do not need to set it ourselves. So I'm just not going to set it. There you go. Probably a little bit simpler. So for the last part, I want to add one more thing because I'm not able to see very well the distribution of the times over. So the last thing I want to do is I want to add one more graph. Partly because I want to show you how to display more than one graph, but also because I want to see better what the distribution actually looks like. So I'm going to copy paste all of these things. And then we'll figure out how to make it a little bit simpler. But for now, I'm going to do a histogram here. And the histogram, it's going to do something really similar. It's going to lock and unlock also. And plotter.xys. So I'm not sure we're going to be using that one anymore. We're going to be using, for sure, a plot. So that is good. There's going to be distribution. We're gonna use probably this. Y in this case would be how often it appears, and X will be the milliseconds. So what are we going to add to our plot? So we're gonna do a plotter.new hist. We have either hist or histogram, and they're pretty similar. The only difference is hist gets a valuer. Which is an interface that, given an integer, returns a float, while xwire is the other one that we were seeing, that for each position you get x and y. So basically this one is a little bit closer to what we want to do, and probably the one that I would have used in the scatter if that was available, but apparently it's not. So if we do a new histogram, we're gonna give our values, and that's gonna be histogram. If we cannot create it, returns errors. The wrap of error could not create histogram. And what are those values? Well, it's going to be plotter.values, because values, I think that satisfies the valuer interface. Perfect. So we're going to simply say for the range as a data. Actually, as before, we can also do make and set to the length of the data, since we know it from the beginning. And vs of I is going to be float 64 of d divided float 64 of time done millisecond. Cool. I did something wrong. Did I? Not enough arguments in. Oh, you need to say how many pins you want in the histogram. Let's go with 50 to start with. Okay, so that looks like it compiles, and I want to show it too in the web page. So I'm gonna need to do hist.png and also create this. So hist and hist. Cool, so now once we have this, if we refresh the page, you should be able to see that we have two different things. We have first the endpoint latency, which is exactly how the points on time. While here it's a distribution, and we can see that this is pretty homogeneous between 0 and 1000, which is what I expected, right? But let's play with this a little bit and change the data. So instead of using rand float, I'm going to use norm float 64 that returns something from, it does a normal distribution over 0. So I'm going to do 500 plus that, and we're going to multiply it by 200 times this. So it's going to create a normal distribution around 500 milliseconds, and with 200 as the standard deviation. So if we use that one now and we refresh, we should be able to now we start to see that normal distribution that we expected, centered around 500, and then you can also see that it's still around 500, but it is more rare that to have values around this area, and that is because it's a normal distribution. So that is normal. Fun. We're repeating things a little bit more than I would like to, especially this writer 2 is done in two different functions. If we could try to put that together to have better code, but I feel like this episode was long enough, and it was not really about code quality in this case. It was mostly about how to use the plotter. I hope you enjoyed it. If you made it till the end of the episode, thanks for watching, and sorry for not releasing an episode last week and for releasing one late this week. I've been traveling, I left Google, I now work for a new company, and I will tell you more about it on Twitter if you follow me on Francesc. But anyway, I'm going to continue doing these episodes. Maybe once a month instead of twice every month. I need to see how I'm able to do this, because now I'm going to be traveling again to Brazil this time for GopherCon Brazil. So it's gonna be hard to get these videos going on, especially because I don't have a camera anymore. I'm recording with my phone today. I hope the quality of the video was not too much of a problem for you. Anyway, thanks so much for watching, and see you all in 2 weeks.